All right, today we're going to be talking about Learning Objective 6-3, which is all about waves in changing media. Learning Objective 6-2 talked about the fact that high frequency waves will have a short wavelength. They look like this, whereas low frequency waves will have a long wavelength. But that actually depends on one important fact, which is that the velocity of the wave is staying constant. It's only if this value stays constant, the frequency and wavelength have an inverse relationship. If the velocity starts changing, then these no longer have that inverse relationship. And so today we're going to be talking about situations where the velocity does change, and the things that cause the velocity to change are changes in the media or medium that the wave is traveling through. So one specific example for that would be that if sound is traveling in air, it's going to be slower and it's going to be faster when it's in water. And this is shown in this picture. You've got your sound wave right here. The reason that it's traveling slower in the air is that air is a less dense medium, so the particles are farther apart. And so the time it takes for one particle to run into the next particle and create this compression wave that is sound, it just takes a little bit longer. There's a little bit more of a delay, whereas in the water, the particles are much more densely packed. There's a lot more particles together, and so the wave is going to travel faster. Now, here's what you got to think about. You got to think about the moment when these waves are coming here and they're hitting the surface of the water. They're at a certain frequency. They might be, let's say, like 400 hertz. So there's 400 waves hitting that water each second. And each time a wave actually impacts the water, it's going to create a wave in the water. And so in the water, the wave is also going to be 400 hertz. There's going to be the same frequency outside the water as there is inside the water, okay? But I want you to see that when the wave speed changes, that's going to change something else about the wave. So here you have these waves going relatively slowly at a frequency of 400 hertz, and here they're going faster at a frequency of 400 hertz. What that does is it stretches the waves further apart. So over here, the waves are relatively short and fast, or short and slow, whereas here they're going fast and they're longer. So this is different from what we talked about the other day, and to write that with the equation, what we're saying is that you're taking this normal equation that we talk about, and the wave speed is increasing, it's going faster, and so something on the other side of the equation has to increase too. So we went into a lot of detail. The frequency is going to stay the same because there's still 400 waves being generated each second in the water, but the wavelength is going to get bigger in order to create that, in order to make the equation work, in order to have both sides still be equal. Okay, so let's make sure we write that down in here. So it says when the waves speed up, the frequency remains constant while the wavelength increases. All right, let's do just a little bit of highlighting here. So we're talking about the wavelength right there, which we're highlighting in purple today. We're talking about the wave speed right here, which we're highlighting in green, and then frequency is this sort of light blue color. All right, so frequency remains constant, wavelength increases. And again, we can see that right here in the equation. So like we said, in both of these situations, the frequency is the same. the wavelength is higher where you have a high speed, and it is smaller where you have a low speed. Okay. Now, in order to predict the change when a material or when a wave moves from one medium into the other, we need to think about what kind of wave we're talking about. So when we think about sound, we need to remember that sound is a vibration of particles. It might be air, it might be water, it might be a solid, like water. Sound can still travel through solids like the earth. And it says if the molecules are more dense, then that vibration is going to propagate, meaning like travel through the media faster. And in fact, I'm even going to label this word propagate. This is a word we use specifically for waves, and it basically just means like move. To give you a comparison, we would say that sound is like dominoes, because the particles are running into each other. And so if you think about this picture, if you have dominoes that are really close together like you do on the bottom, they're going to go faster, whereas dominoes that are more widely spaced are going to go slower. Okay, so if you remember, sound is kind of like dominoes. You just have to think about, is the medium more dense, more closely packed, or is the medium less dense and spread farther apart? Cool. Now, if we talk about light, we're talking about something very different. Light is an electromagnetic wave, and it travels through empty space. Particles, like air particles or water particles, absorb and reflect the light, or they absorb it and re-emit it. Sometimes they just absorb it and block it completely. And so particles slow the light down. If the medium is more densely packed, the light particles will be slower. So light is like basketball. Okay. The more people that you are passing the basketball to, the slower the travel of the basketball is going to be, because each person has to catch the ball and then throw it again, and then catch and then throw. And so the situation on the bottom where there's only a few people to catch the ball is going to be faster. So for a basketball, closer means slower. Same thing with light. The particles in the water are closer together, and so it's going to slow down the light. I also want you to see not just the speed, but I also want you to look at the wavelength and notice that the waves, this is going to be in purple. The waves right here are long, and then it gets into the water, they slow down and they kind of get crunched. And so you get a shorter wavelength in the water because the wave speed is slowing down. Remember, what happens to the frequency? The frequency stays the same. All right, so that is what happens when waves travel from one media to the next. I want you to really remember that the things that change are the speed based on the density of the media and the kind of wave, and the wavelength also changes depending on how the speed changes. The frequency stays the same.